Hello. I would now like to discuss file descriptors and file input-output in C. As I'll show you, this is pretty simple and very similar to the patterns that we've used to input information from the console and output information to the console. So first, let me tell you about what are known as file descriptors. So I'll give you two examples. One is called stdout and the other one is called stderr. So to tell you a little bit more about these, let me go back to the simplest possible program I can make in C, which is hello world. Alright, so just to make sure that this actually works, I compiled it and it worked. But I can also be a little bit more explicit about exactly where I'm sending this string. And I can say, use this other method called fprintf. And I can say fprintf stdout hello world. And this will do the exact same thing, just to show you. But now I'm being a little bit more explicit and saying, okay, this text I want you to send to a file descriptor called stdout. Now, file descriptor is a stream. This is a kind of a pipe that we write data to, and it goes in one end, it comes out the other. I can actually get a number associated to each stream. So let me show you what I mean. If I say file no stdout equals that, there is an integer associated to each file descriptor stream. And for stdout, it's always 1. Okay, so let me show you what I mean. Okay, so that's always 1. Every time I run the program, it's going to be 1. Let me now look at the file descriptor for stderr, and then I'll look at what happens when I print to this, when I fprintf to stderr. Okay, so stderr always has a file descriptor 2. Let's try to write to stderr now. As you might have guessed, this stands for error. So what I can do is say the following. If I say fprintf stderr, this is an error. And I'll compile this program. Well, I see hello world, and I also see this is an error. And you might be saying, well, what's the big deal? You know, they both output to the terminal. Well, if I were to run this program and pipe the output to a text file, notice that it still prints out the error part, but it piped the stdout part to the file. Okay? I can also decide, hey, you know what? I want to log the errors. And now I can be explicit about the file descriptor. So as I said, stderr is always file descriptor 2. So it turns out if in the terminal I put 2 and then the right angle bracket, this will pipe only stderr to this file. So now it does the opposite, where it goes ahead and it continues to print stdout to the terminal, but it actually pipes the error to the file error.txt. So let me show you here. Okay, there we go. Error.txt. All right, so I actually piped what I printed to stderr here to an error file. And so this is very useful when you're creating log files of programs, and very useful in debugging. If you want to print stuff, but you don't necessarily want to clutter your terminal, but you do want to keep track of errors, you should print to stderr. And it's a good convention to print error messages to stderr for this reason. All right? So, as I said, stdout is always file descriptor 1 and stderr is always file descriptor 2. Now, as it turns out, to write to actual text files or binary files, we kind of use the same idea. In this case, what I need to do is create a new file descriptor that's going to be different from stdout or stderr, and a general file descriptor is referred to as file star. So actually, just to show you, I could actually set this to be stdout and say fprintf file some more stuff or some test text to a file. This should actually print. Let's go back and compile this. Okay, some text to a file. So just to reiterate, std out is a file stream. It's a stream associated to a file descriptor. I can assign that to this type, file star. That's the stream type. But I can also make this a totally different file. So I can say, okay, let's open some file. I'll call it maybe myfile.txt. And actually, if I look at the man pages for open, what I see is that this is going to take, oh, actually it doesn't show it here. But, okay, I'll just tell you. The first parameter is the name of the file, and the second parameter is the type of interaction we're going to be doing with this file. So if I say W means write or overwrite if it's already there. There's also a method called A, which does append to what's already there. And there's also a read. There's also a read method. If I were to use fscanf instead of fprintf, I could read from these file streams. All right. So this would be read from file. But right now I'm going to write to the file, and that will just overwrite if there's anything there. So just to show you, if I make this program and oh, I meant to say fopen. Okay, that's why I wasn't getting the right man pages. Fopen. There we go. Now it tells me, okay, path name and mode. And so yeah, here it tells you more information about the modes. I only gave you R, W, and A. There's more options you can open for reading and writing, so on and so forth. So you can read the man pages there. But okay, so let me test this as it is. And I run this, and yeah, I'm still printing the same stuff as I did before, but now I have this file called myfile.txt. And let me move this up. Okay, so there we go, myfile.txt. And if I look at what's there, I will see some text to a file. That's great. If I were to put something else in this file, so let me say, if I were to say echo blah out to myfile.txt. So now my file has something different, but if I were to run this program again, it would actually overwrite what was there. Okay, so that's what the W mode does. But just to show you, if I switch this to A, then that will actually overwrite what's already there. So now if I make this program, again, and I run it, then I notice it actually wrote that thing twice. And now if I run it again, you'll see it there 3 times. So this is just going to append to the file what's already there. All right? And of course I can get very fancy, and I can just do anything that I would do with printf, and I can have format strings and things like that. All right. The only other thing that I want to mention here is, this works for writing text data to a file, but sometimes you also want to write binary data, and you'll be doing this in homework 2. Just to tell you that there's also methods called fwrite and the analogous thing for inputting fread. So I'd encourage you to look at the man pages for fwrite. It's similar kind of idea, but you can actually write binary data. All right. But the cool thing about fprintf with these file descriptors is that you can actually just do it like printf and write to files instead of writing to the terminal. Oh yeah, and then the last thing I should say is make sure you close this when you're done. Especially if you're opening a bunch of files in a loop. What will happen is, actually each time you open a file and you look at the file descriptor, so I'll say file no file. Remember I told you that the file descriptor for stdout and stdir are 1 and 2 respectively. What will happen if I make a new file is that will be usually 3. Okay, so it'll kind of give me the first available file descriptor, which is 3 in this case. If I make another file descriptor that's for a different file, that'll be 4. So if I'm doing this in loop but I don't close this file, then I'm going to eat up too many different file descriptors and I can't reuse any of them. So it's important to close the file at the end. All right, but that's it. Pretty simple stuff. So I'm just going to ask you a couple quick questions on Canvas, and then I'll have you watch a video about sockets, and we'll see that sockets are an abstraction in the application layer for communicating with networks that from the perspective of C code actually looks like a file. And so what we'll do is get a file descriptor for something called a socket, and when we write to it, it's actually like going to write to another computer. Okay? So there's this nice abstraction we can do in C, and that's what we're going to be working towards next.